All right, 7.2 is on trig integrals. The two main tools that we're going to use in this section are U substitution and trig identities. So the first, and I would say the simplest of these, are integrals of this form where you have sine raised to a power of x times cosine raised to a power times x. And before I do any strategies or anything, let's just look at sort of a starter example. So suppose we want to integrate this thing. We could do this with U substitution. The idea here is we're going to take this cosine x dx. We want to use that as our du. So what I'm going to do is let u equal sine x. And so du is going to be cosine x dx. So we can rewrite our integral as integral of u squared du. And now this is a really easy integral to do. It's just 1/3 u cubed plus c. And we can rewrite that as 1/3 sine cubed x plus c. All right, and this same sort of basic strategy is going to work anytime that at least one of our exponents is odd. So here's the idea. If suppose cosine has an odd exponent, then you let u equal sine x, and du is going to be cosine x dx. And then, this is unfortunate, it wrapped, but you use sine squared plus cosine squared equals 1 to rewrite everything in terms of sine. So let's look at this example. We've got sine cubed x cosine to the 4th x dx. Well, first up, rewrite this as sine squared x cosine to the 4th x, and then sine x dx. So really, you're sort of saving one of those odd, whichever function was odd, you save one factor of it out to be part of your du. So I'm going to let u equal cosine. Du then is going to be sine x dx. Actually, it's going to be negative sine x dx because derivative of cosine is negative. If you ever get confused about these things, remember the derivative of a cofunction is always negative because derivative of cosine is negative sine, derivative of cosecant is negative cosecant cotangent, and so on. And anyway, back to this problem. So the sine here is, we've got to rewrite the sine. So I'm going to rewrite the sine using this. Sine squared is 1 minus cosine squared. And now I can rewrite all of this with u. This becomes 1 minus u squared. Cosine to the 4th becomes u to the 4th. And then sine x dx becomes, let's see, negative du. All right, so let's see. I'm going to pull my negative out front, and then I'm going to distribute these together. So you get u to the 4th minus u to the 6th du. And let's see, what next? I'm going to get fancy here. I'm going to distribute that negative in and get u to the 6th minus u to the 4th. And now I can integrate this thing. So this is going to be 1/7 u to the 7th minus 1/5 u to the 5th plus c. And I'm practically done. I just have to replace each of those u's with the cosine. So 1/7 cosine to the 7th x minus 1/5 cosine to the 5th x plus c, and I'm done. And that's all there is to it. It's kind of long, but let's look at the next one. Okay, on this one we've got sine to the 7th and cosine to the 5th. So the truth is we could pull either of these off. We could either do sine to the 6th x cosine to the 5th x sine x dx, Or we could separate one of the cosines off and get sine to the 7 x, cosine to the 6th x, or no, 4th x, cosine x dx. We could do either one of these and both of them would work no problem. But this tip over here says, if both exponents are odd, let u be the function with the higher exponent. So in other words, we want to save off, well, we want our u here to be sine. So that means du needs to be cosine. So this is going to be the one that we want to use. And again, they'll both work, but this one will be a little less work as far as the algebra goes. So let's go with that. We're going to go with that one, and we're going to let u equal sine x. Du is going to be cosine x dx. And so I'm going to rewrite this as integral of, let's see, u to the 7th. Now, cosine to the 4th. We've got to deal with that 4th power here. And here's how we do it. I'll tell you what, I'm gonna hold off. I'm gonna keep this in sines and cosines for now. This is sine to the 7th x. I'm gonna rewrite that cosine to the 4th as cosine squared x squared cos x dx. Because now we can replace this guy here with 1 minus sine squared x. So I can rewrite this now as integral of, let's see, my sines turn into u's, so I got u to the 7th. This becomes 1 minus u squared squared, and cosine x dx is just du. All right, so we've got to square that out and multiply it out. So I get u to the 7 times, this becomes 1 minus 2u squared plus u to the 4th du. And then multiply the 7 across there, the u to the 7th across there, u to the 7 minus 2u to the 9th plus u to the 11th. Let's see. So this becomes 1/8 u to the 8 minus, let's see, 2/10 u to the 10 plus 1/12 u to the 12 plus c. And then of course you rewrite that, I shouldn't use an arrow, this is equal to. Replace each of those u's with the sign, so you get 1/8 sine to the 8x minus 2/10, also known as 1/5, sine to the 10x plus 1/12 sine to the 12x write this a little more legibly, sine to the 12th x plus c. All right. Now, if we had done this using the other, if we had done this using this over here, it would have worked just as well. The difference is we would have had to rewrite it as, let's see, sine to the 6th. We would have had to rewrite that as sine squared x to the 3rd. And there's nothing wrong with that, but if you come in here, when you replace this sine with 1 minus cosine squared, you'd have to cube that. And that's a bigger pain than coming down here and having to square this out. So both of them will work. Both of them will give you different looking answers. One will be written in terms of sines and one in terms of cosines. But either way works just fine.